What's poppin', Gen Chem squatters? Alright, so this video will be a general tutorial of how you should process your data using Excel. So like making graphs, organizing tables, just stuff like that. Not quite sure how I'm going to get this to you guys, but it's all done in one cut, obviously. So we'll see how this goes. But okay, so to start out with, you need to put your data in Excel in a format similar to this. So on the left here, the average calibration. This is just information from your calibration curve you would have procured. This value is the slope. I understand the way you wrote it down was probably 5 point, or some number point something times 10 to the fourth. I just expanded the number out, so don't worry about it. And then this value right here is your y-intercept. Ignore all the calculations up here. These are just the values I'm going to be using. So whatever your calibration curve data is, that's what you would want to put right here, for example. These two columns right here, the one on the left is time. That's your x-axis. You should have measured every 2 minutes, so 0, 2, 4, so on and so forth, up until 30. If for whatever reason you did it a different way, where you measured twice a minute, so you would have 0, 0.5, 1, 1.52 minutes, so on and so forth. You can still take that data and just copy and paste it into Excel, and then from there you could delete the 3 numbers in between 0 and 2 you don't need, and then the 3 in between 2 and 4, and then you could kind of scrunch your table up to look like this using various copy and pastings. I'm not too concerned about how you guys are going to set that up, because really the only part of this that I need to see is the graph. So as long as you get to the end and get the K value that you need, everything should be fine. So, all right, getting started. Classic procedure for setting up a graph of anything is you would select both columns. So x-axis is usually on the left, y-axis is usually on the right. Keep in mind that this is the downloaded version of Microsoft Excel. So the online one can sometimes behave a little differently. Updates might be different, but this is the version I use. I suggest you do the same just for convenience. So if something doesn't work in the online one, try downloading it, and then hopefully it works from there. So you're going to go up to Insert next to Home, and somewhere in the middle there should be a button labeled Recommended Charts. So you click that. It's going to pop up a bunch of different options. We have bar graphs, funky pyramids. I don't know why you would use any of these, but this top one is the one we are looking for. This one would be acceptable, but in this case, because we have a certain number of discrete data points, this one would be preferred. So when you select the chart you want, you're going to click OK, and it should generically just slam the chart down right there. It automatically selected absorbance as the title. You can very easily change this, so don't worry about it. But while you have the chart selected, on the right here there will be a plus button, chart elements I guess. You'll click that, and there will be a box for axis titles. If you hover over any of these, it will kind of show you what it will do to your graph. So you want axis titles for sure. So we're going to say okay, cool, and that will then pop up 2 boxes conveniently labeled axis title. You want to click within one of them, delete whatever they wrote in there, and you're going to want to put in whatever the label for that axis should be. So in this case, your y values are absorbance, which is the y-axis, so you would write absorbance. As for the units on absorbance, I'm fine if you omit them. I don't know off the top of my head what they actually are. It might just be absorbance units is like the name, but you can just write absorbance. That'll be acceptable. But for the axis title, on the x-axis, we know what that is. It was time measured in minutes. So you can write time, and then in parentheses, min for minutes. I will know what this means. That's a good way of putting it. So now you've labeled both the x and y axis. The title, we don't want it to say absorbance. So classic rule of thumb for the title for a graph, just explain what it is. So it's comparing absorbance versus time in minutes. Very convenient, very easy to do. So something like that would be acceptable. I know some people label their charts as, or their graphs as something like experiment 3. Like, I mean, that's fine and all, but it's more about what specifically is your graph talking about. Because I believe on this experiment, we're going to need 3 or 4 graphs. You need to show me a graph of your calibration curve, which you should have all been able to successfully export from Logger Pro. I believe we talked about that. If you haven't, you can just email me, and then I can help you figure that out. You need to have this chart that I just made, which is the absorbance versus time. And then you're going to need one more chart for week 1, and I believe you'll need to make another one for week 2, but I will show you the other chart now. So this is the easy part. I know not all of you got data, which is kind of the reason we're doing this. So as for the numbers you're going to use in order to plot like these two data sets, obviously we know time is measured 0 to 30 minutes, but you guys don't necessarily have absorbance values. So I worked that out. It's finished. I will generate a set of absorbance values for each of you to use, and I will send that out to you guys in probably groups. I'll figure out how specifically I'm going to do that, but sometime today I will send out that data and hopefully have this video uploaded somewhere where you guys can look at it, and we'll be able to go from there. So, okay. So in order to figure out, if you guys remember the math, it's somewhere in your book. You need to plot the natural log of the concentration versus time, and then the slope of that line is negative k, so the negative rate. But we kind of have to get there first. So we need concentration in order to take the natural log of concentration. So the way we're going to do that, so you're going to label your column concentration, because that's what it is. Probably put the units on that, moles per liter. And then in the column next to it, for Excel, if you're typing in a box and whatever you're typing is longer than whatever the box is, if you hit enter, it's probably not going to change anything. But if you go up here onto the right border of that cell you were typing in and you double click, it will automatically expand the cell to contain whatever text you had. So in this case, for concentration, the moles per liter goes into column G. We don't want that, so I'm going to double click on the right side of F at the top there, and it will expand it out. I like to put everything in boxes so I can see what I'm looking at, but it's just personal preference. It's really up to you. The column next to that, we're going to want to write the natural log of concentration, the units of which are kind of funky, so don't worry about it. Double click the right side of that to expand that out, and there we go. So, good rule of thumb is do all your formatting afterwards, because when you copy and paste stuff, everything gets kind of wonky, like all your nice box borders kind of get messed up, so I wouldn't worry about that too much. But for determining concentration, you want to set up an equation to do all of this math for you. Technically, you could go through each and every one of these absorbance values and set it up using the formulas that we talked about in class, but that's kind of inconvenient, and Excel will do all the work for you. So here's what we're going to do. You're going to start with equal sign. That's how you set up an equation. I'm going to do an open parenthesis, and then I'm going to select the cell that I want to do the math for. So in this case, in order to calculate concentration given absorbance and a slope and a y-intercept, you need to solve for x in the y equals mx plus b equation, where y is your absorbance value. So we have the output. M is the slope, which we have been given. X is your concentration, which is what you want to solve for, and b is the y-intercept. So we have every value except for x. So you have to do some basic algebraic rearrangement to try and solve for that. So in this case, we are going to go with whatever our y value was. So in this case, absorbance. And from that, you would subtract your b value. So I will select this cell right here. So that way it will always pick from right here for the b value. And parenthesis, because the order of operations is important. And you would then divide that by your slope. So this value right here, C13. If I hit enter, it should calculate the concentration. Fantastic. Okay. So, funny thing about equations, instead of retyping in equals yada yada in the next box, what you can do is you can click on the cell that has an equation. You can click on the bottom right corner so you see this black plus sign, and you can click and drag downwards. Now what this will do, ignore this, I'll explain why that happened, is it will automatically start selecting. You can see right here it used E13, which is this box right here, so it used this absorbance. When you click and drag downwards, it will then swap to E14, which is the one below. So Excel will try and automatically update your formula to accommodate different things in different columns. Now the problem is, it says that it is dividing by 0, because if you look at where the slope value is coming from, C18, it is selecting boxes that are empty. If we look, oh shoot, If we look at this cell right here, it's looking at these two, 17 and 18. If you select this one, it's looking at 15 and 16. So only these two managed to come up with numbers because they divided by not 0. So in order to fix that, you don't have to rewrite your slope a billion times or your y-intercept somewhere else. What you can do is go back to the original function, and considering C14 and C13 are the numbers that we want our equation to use constantly and to not change, what you can do is you can put a $ in front of both the letter and the number. So $C, $14, $C, $13. Now what that will do is change nothing for the first box. Nothing will be different. But if we click here and we drag down again, you see that we get numbers. So if you click on each of these, this one is using this absorbance value, which is the thing that's changing, and then our two constants, our slope and our b. So if we hit enter, if we go into this one, it's using the next absorbance and still using that slope and that y-intercept. So if you look at each of these, they all do that. It's just a neat little trick. So if you ever get a bunch of divided by zeros or errors, don't worry about it. Just maybe you need to make sure that you define that you want those constants to continue being used. Okay, that's how you get concentration using the classic y equals m times x plus b, where x is concentration and y equals absorbance. I believe most of you guys kind of got that. So obviously if you have more questions, you can email me. But for the most part, you can just back up the video and then listen to when I explained it the first time. So that's kind of neat. And then natural log of concentration, we are also going to be using a system of equations. So hit equals, set up another equation. And the command for doing the natural log is conveniently capital L, capital N, open parenthesis. Now the number we want to use for this is the one right next to it. So we want this output value. This is our concentration. Hit the end parenthesis, hit enter, bam. That's the designated natural log. So similar to this absorbance column and calculating concentration from that, you can click here, drag down. It will then autofill where it's using F13, so this value. Go down a couple more, it'll be using F17, which is this value. And all is fine and dandy. It's pretty hard to get errors when you do a basic column by column equation like that because you're not using these constants, so you don't have to like do the $ thing to define what they are. So that's all good right there. I'll just format it a little bit so I can see what I'm looking at. Okay, and now the things I want you to plot, this is the absorbance versus time, which you can see is these two data sets evaluated. And what I also want you guys to plot is the natural log of concentration versus time. So in order to do that, when most people try and select things, they will just click and drag in order to select as many boxes or as few boxes as you want. And that works very well when your two columns are right next to each other. However, when they're separated, like time is over here and natural log is right here, you don't have to rewrite time over here. What you can do is you can select these normally, let go of the mouse button, then you come over here, you hold control on the keyboard, and then you click and select these and then let go of control at the end and your mouse. So now I've selected these two data sets instead of time and absorbance, for example. We're going to do what we did before. Go up to the Insert tab, go to Recommended Charts, and we're going to go for something that looks like this. And what you want from this graph of time versus natural log of concentration is a straight line. If you compare the natural log of concentration with time, that means, as you guys learned in lecture, and I believe as it says in the instructions for this lab, that is a first order reaction, which it is. It's supposed to be first order. So if you get something like this, that's good. Considering I'll be giving you the numbers, I think you're guaranteed to get something like this as long as you set up the equations correctly. So you're going to hit OK, add that in there. Cool. Similar to the first graph, you're going to go over here. You want to add axis titles. And for this graph, because it is linear, we are going to want to add a trend line. So what you're going to do, you're going to click this black arrow right here, hit More Options. You're going to make sure that it has linear selected, so it should have added the line. And what you want to do, in this case, similar to extrapolating stats from log or pro, you're going to go down to the bottom, and you want to display the r-squared value on the chart. That should pop up. And you want to display the equation on the chart. So that should give you these two. You can then exit this. You can click on either of these two equations, and it'll pull up a little box. Move it somewhere where you can see it a little better. And looking at this information, this is how you would determine the actual rate of the reaction. So the R squared is that correlation number that Logger Pro will give you. It's pretty much the exact same calculation. It just tells you how well that line that it generated fits your data points. And then up here, you have the y equals mx plus b for this concentration. Now, as I talked about in class, the slope of this line is equal to the negative of the rate. Or another way of saying that is the rate is equal to the negative slope. So you want your rate to be positive. So the fact that this slope is negative is a good sign. So you're going to take the equation that the rate, which I believe is k, equals the negative slope of natural log of concentration versus time. And then you would then write that k, in this case, equals positive 0.0563. That would be your answer. So, as for what the correct k value is, that's not super important. It's getting there that matters. That's for me to worry about later. But you should be getting a number that is positive and relatively small. So, something like this would be fine. You want your r squared to be above 0.95. In this case, 0.9978 is pretty good. And essentially, that's about all I need you guys to do. Properly change the title of this graph to just be natural log of concentration versus time in minutes. Easy as pie. This one down here is time in minutes. This title over here is the natural log of concentration. Okay, so these two graphs you can then have right here. I do not want you to turn in the Excel sheet to me. What I want you guys to do is to use either the snipping tool or I think on Windows you can do Windows Shift S, and then you can just highlight whatever you're going to be looking at. I don't think that'll pop up on the way I'm recording the video right now, but just you should be able to find a way in order to screenshot these graphs and put them in your report. I expect you guys to tell me exactly what this k value is, which you will be able to determine using this equation right here from this output, y equals mx plus b. And that's pretty much it. That's kind of a crash course in Excel. Hopefully this video is at least a little helpful. You can back it up, watch it again. You can literally follow exactly what I did step by step with your data. You can set up these exact same tables the way I did, because this is the starting information you'll get. Your absorbance values will be different, but they'll be pretty close. And from there, you can just set up all this stuff exactly the same way I did. Type in the exact same equations. Make sure you capitalize certain things, like ln should be capitalized. So don't do two lowercase letters. It might still work, but it will probably autocorrect it anyway. But yeah, so that's that. I can save that. And with that, if you guys have any additional questions afterwards, let me know. You don't need to write a lab report for this coming Thursday, so there's nothing you're going to have to write. Just make sure that you get this data and that you have a calibration curve. That's an important thing. If you don't have the calibration curve, I'll probably just end up sending it to everybody anyway and say, hey, if you don't have one, use this one, because we know this one kind of works. Besides that, that's kind of it. Please, 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 I'm begging you, please. I wasn't joking. Read the pre-lab like 3, 4, 5 times. Make sure that you know what you're doing. And just please make sure that you read it. So, thank you guys. I will talk to you Thursday. See ya.